Welcome to physics tutorial. So today we're going to be looking at current electricity. Meanwhile, current electricity is kind of wide. So there are different aspects to current electricity, but what I want to do today is just an introductory aspect of current electricity. Now, in electricity, we are going to consider just Ohm's law. And I will not be stating the law. Meanwhile, under Ohm's law, we have three variables that we are looking at: current, voltage, and resistance. Now, these three are connected together in such that now in a conductor, these three are related to each other. And the fastest or the easiest way to understand the relationship between current, voltage, and resistance is take, for instance, you have a pipe that has water flowing inside. Now, we are going to say the pipe is the conductor, right? Now, the water is passing through the pipe. And the water passing through the pipe, we can say it's the voltage. Meanwhile, as the voltage is going through the pipe, there is something that is pushing the water. Normally, when you on a tap, the first sound you hear is the sound of an air or the sound of air, right? So that air is what is pushing the water into the pipe. So the current we can relate the current as the air pressure that is pushing the voltage. Okay, now as it is going through the pipe, there's what we call resistance. There is something that does not want the water to pass through. So that thing is called resistance. So we can relate it the same thing with a conductor. So the voltage is passing through a conductor, and the current is the force responsible for pushing the voltage. And then the conductor has what we call the resistance standing against the voltage. Now, I'm going to skip all of this and go to arrangement of cells or arrangement of resistance in a resistive circuit. Now, we have two kinds of arrangements. We have parallel, and we have series. So these are the two kind of arrangements we have. Two kind of arrangements. Now, if you have a battery of cell or you have a battery that is direct current that dispenses direct current, now you can do a parallel connection or a series connection of those batteries. Now, take for instance, I have two. This is 1.5 volts. Another battery is 1.5 volts. And these are two terminals. This is negative and this is positive. Now, in series connection, don't forget this is done only in batteries or any cell that has that gives direct current. You don't do that in alternating current, you cause problem. So for batteries, look at it: plus, minus, the positive to negative, negative to positive. You discover that for series, if you arrange batteries in series, you now have at the end you have a positive connection and a negative connection. Now the combined voltage will now be 3 volts. That's what you see in your radio set. That's why when you arrange batteries in a radio set, if you need 12 volts to power a radio, so you can arrange maybe 3 volts or 4 volts batteries to give you the final output of what? 3 volts. Now in this same battery, let's assume you just need an output of 1.5 volts. What you do is you arrange it now in parallel. This is minus, plus, minus, plus. So arranging it in parallel means negative terminal to negative terminal, positive to positive. So you, at the end of the day, you still have your plus and your minus. But then the combined voltage will not still be 1.5 because it is in parallel. So this is the kind of connection we use for alternating currents. That's why you discover in your house, your bulb is using the same electricity, your TV is using the same electricity, your fridge is using the same electricity, but the voltage is not dropping. The reason is because they are connected in parallel. So all of them are taking the same voltage. So if that is true, it's going to lead me to the next thing I want to show us before. So resistors in series. So what happens when we connect resistors in series? Now, when we connect resistors in series, we are going to see it from the equation. Now, Ohm's law is V is equal to I R. Now, this is resistor. And we know that every resistor takes voltage and takes current. So when you pass a resistor, when they are arranged in series, now this is what we call series arrangement, just like I explained here. So you have one resistor here, you have another one, you have another one. This is R. So this is what we call resistors in series. Now, these are conductors connecting them, right? Now, something happens here. You discover that when a voltage is passed through this resistor takes a certain amount of voltage. This resistor takes a certain amount of voltage. This resistor takes a certain amount of voltage. So when we add them, we get the total voltage. And these are separate resistors. So from this equation, you can see that we have two variables. Voltage is changing, while resistor or resistance is also changing. What is constant between all of them is the current passing through them. So from V equal to IR, we can say that for resistors in series, the first thing is that voltage varies. Okay, resistance resistance also varies, but the current is constant. So based on this, if you want to find the combined resistance of resistors in series, we just say RT here. I mean total resistance is R1 plus R2 plus R3. So for every given circuit, current is constant. You want to find the voltage, you are going to add the combined resistance of the circuit so that you can get your voltage. Okay, so let's look at the other one. Resistors in resistor in parallel. Okay, now resistors in parallel. Parallel arrangement means the same thing I just explained here. When two terminals, positive and negative, are connected, so this is three resistors. Yeah, these are three resistors. So we can see here is negative, here is positive. So you can see all the negative part of the resistor connected to one place, all the positive. So this is R, R. So we know that from V is equal to V equal to IR. Now remember what I said here. When you connect cells in parallel, something happens. The voltage is the same. So if the voltage is the same, you can do it here. So let's rearrange this equation so that to give us something like this. I is equal to V over R. If you follow the last video we did on graph, when we connect this to a straight line equation, we are going to have that I is equal to V dot I R plus 0. So where we are plotting a graph of I against inverse of resistance, your slope or your constant is voltage. So if that is true here, what is constant in resistors in parallel is that the voltage is constant. So the current varies. So the current here is different from the current here and different from the current here. And the resistors, so current is directly proportional to the inverse of resistance. So if you want to find combined resistors, so total resistance for resistors in parallel is given as this: 1 over R is equal to 1 over R1, 1 over R2, up to 1 over Rn. So with that, if you have resistors in parallel and you want to calculate the current flowing in the circuit, you use this method, find the combined resistance, then multiply by the voltage of the cell, and then you get your current passing through. So I'm going to stop here. In the next video, I'm going to give us some examples and see how all of this works. Thank you very much for watching.